China just detonated a shockwave in the AI race, so big it's forcing the entire industry to stop and rethink what's possible. Not someday, not in theory. They say it's running right now in aerospace, biomedicine, finance, and other industries that live and die by computational speed. For years, quantum computing has lived inside cold, oversized labs surrounded by cables, liquid helium, and million-dollar hardware. But this time, the breakthrough isn't trapped behind laboratory walls. A Chinese research team has built a quantum photonic chip that actually works inside real data centers. And they're claiming performance numbers so extreme they sound like science fiction, up to 1000x faster than NVIDIA GPUs for certain AI workloads. The chip comes from ChipX, partnered with Turing Quantum, and together they introduced what they call the world's first scalable, industrial-grade optical quantum chip. The shocker? It's tiny. Instead of a giant room filled with equipment, we're talking about a 6-inch thin-film lithium niobate wafer, holding over 1,000 optical components packed into a single piece of silicon. That's the magic of photonic integration. Everything shrinks, everything speeds up, and everything runs cooler. What makes this chip so different is simple. It uses light instead of electricity. Photons don't overheat. They don't slow down. They don't lose energy the way electrons do. And because they move faster and through far smaller pathways, data flows smoother, cooler, and dramatically more efficiently. With data centers drowning in heat and energy demand, this approach hits directly at AI's biggest bottleneck. Of course, that 1000x faster than NVIDIA claim turned every head on the internet. It came from the South China Morning Post and the chip's own engineers, who say these accelerators multiply problem-solving performance by 3 orders of magnitude for very specific workloads. Not everything, just the kinds of algorithms where quantum-style parallelism and photonic pathways absolutely dominate. And it gets even better. Traditional quantum systems take months to assemble and calibrate. This chip? ChipX says full deployment drops from 6 months to 2 weeks. That's unheard of. It's not a full universal quantum computer that breaks encryption. But it is a programmable photonic accelerator combining the precision of quantum logic with the practicality of classical control. The monolithic design, everything baked into one wafer, was what stunned Western researchers. It's compact, elegant, and incredibly efficient. Its creators already won the Top Technology Award at the 2025 World Internet Conference, beating out more than 400 global competitors. And China isn't hiding its ambition. They've already set up a pilot production line capable of turning out 12,000 wafers a year, roughly 350 chips per wafer. For quantum-class photonic hardware, that's a huge head start. Sure, yield challenges remain. Thin-film lithium niobate is delicate, and consistency is still tough. But China now has a full pipeline: design, fabrication, packaging, testing, and system integration under one ecosystem. Meanwhile, Western photonics is still stuck in prototype mode. While that's happening, NVIDIA, Google, IBM, and Europe's photonics labs are racing in parallel with their own approaches to superconducting qubits, silicon photonics, and indium phosphide platforms, but China may have just accelerated the timeline. These chips slot straight into existing infrastructure without exotic cooling, which means enterprises can run them alongside GPUs instantly. Researchers also say the architecture could scale to 1 million photonic qubits, not the same as superconducting qubits, but still powerful enough to behave like a massive quantum-inspired grid. Photons carry more information per unit of energy, generate less heat, and travel with minimal interference. That means fewer errors, higher throughput, and huge gains for AI training and simulation. To be fair, the claims still need independent verification. No one fully knows the long-term stability or the exact conditions where that 1000x boost applies. But that's how every quantum leap starts: messy, uncertain, and absolutely game-changing for whoever gets it right first. The industries adopting it, biomedicine, aerospace, finance, are the same ones struggling with peak computational pressure. And because photonic chips run cool, stable, and with high bandwidth, they can slot straight into racks that used to rely solely on electric-based silicon. The real turning point, though, is how China framed the announcement. This is the first time optical quantum computers can be considered industrial-grade products. That's not a research milestone. That's a market declaration, and if they're right, the next few years of AI might look wildly different from what anyone expected. We may be entering a hybrid era where photons take over the heavy lifting and silicon handles everything else. NVIDIA GPUs won't vanish, but they may soon have serious competition from hardware that's cooler, faster, and built for the next generation of AI scale. Drop your thoughts below, and if this kind of deep dive tech breakdown hits the spot, make sure to subscribe. The future of computing is shifting fast, and we're just getting started.